guys, Rithia. This is math kmap. It's a concept. Let me show you. So the idea is you have two inputs wires. Zeros represent wires coming out of the page. Ones represent wires going into the page. So there will be fields around the wires. So as you have outputs, 0 and 0 it's a 0, 0 and 1. Adding, it's a 1, 1 and 1, it's a 1, 0. 1 and 0 it's a 1. This other side, 0 and 0 it's a 0 and 0. It's 2 bit, having the first bit as zeros. 0 and 1 it's a 1. 1 and 1 it's a 1, 0. 1 and 0 it's a 0, 1. So having that type of give me a minute. Okay, let's continue. So there is inputs for, these are the inputs for 0, 1, 2 and 3. It's a right, down. Let me say it first. It's a down, up, right, down, up, left. So here is it. This is a truth table, and then there's this one here. So in this, it's formed as boxes. The outputs, the inputs, when this is a 0 and 0, it's mapped out like 0, 0, 1, 1. So 0, 0, 1, 1. 0, 1, 1, 0. 0, 1, 1, 0. This is inverted, it's flipped. So these are the inputs. The magnetic field here for 0 and 1, it will be clockwise, counterclockwise, which will combine to form a down. This is counterclockwise, and this is a 0 clockwise, combined to form an up. Clockwise, 0, 1. This is clockwise, this is clockwise. It will combine to form a right. From there, you can now have a down for the second combinations, 0 and 1. So it's 0 and 1. It's a down, up, left. This will combine. It's a 1 and 1 here. So it's counterclockwise, counterclockwise. It should be this is a left. I mean, yeah, it's a left. So give me a minute. Clockwise, counter. It's supposed to be a right. So yeah, okay, you get. So in the second run, it's this one, 1 and 1. So it's gonna be 0, 1, 1, 0. So it's a 1 and a 1. This is 0. At the end of the day, the concept is, and the last one is a 1 and a 0. So you read for this, for 0 and 0, you read these two, the upper part. For 0 and 1, you read the down part. For 1 and 1, you read here, this one and this one. Let's flip the order for the first one. It's 0, 0, 1, 1. It will still work. So it's both of them are flipped. Times someone forgets. Thanks. Having that, you get now, since these magnetic fields are constants for the various outputs, for 0, 0, 1, 0, we are using fields for faster computing, because like in this region, two wires are combined into one field. Even this, okay, these are opposing, but you get it will be slightly faster. That's the concept, or it's easier to read, so less inputs to do. So you come, this for structured, this is for boxes, so this is for straight arrays combined like this. So you read them like this, like this. The outputs are at the end, up here, right here. There's a left here because of a 0 and a 1. There's a 1 and 1 here, so it's combined. So there's a 1 and 0, goes like that. So 0, 1, you get here 1 and 1 combined going down. Give me a minute. So from there, you read these fields. Having these specific fields, you'll get outputs. So you come up and map. At the moment I've mapped there's a kmap for ups, there's a kmap for downs, there's a kmap for rights, and there's a kmap for lefts. Let me look one that has an output. Let me see. I haven't done the kmap for the outputs, but the outputs will have the same magnetic fields as the, okay, we'll rather have fields same as the input fields. So you map out both of them and read only the fields. So when you feed in these numbers, you'll get, it's on another page and I don't want to flip the page, so please do watch the next video. Sorry, I misplaced a phone. Recorded again. So I'll upload a better way in the next video. Let me just show you. So here it is. In here, the concept was having kmaps for all numbers and letters. So it's like characters. So when it comes to reading, you just read the same fields. Which field, each name, each character will or number will have a specific field. So like this was for P. It will have a straight up, all the wires are coming out. So the rest will be going down. The rest of the, but the main thing is this is constant. These wires are not changing, so it's a kmap for each and every single letter and number, making it slightly easier to read. There's no form of resetting. It's just rereading the wire arrangements. So you can have for each and every character. Come here. These are the fields for okay, that's for that. So you can come here and have a setup of A and B. this is a subtractor, 0 0 0 1 1 1 1 0. So it's 0 0 1 1, I mean 0 0 1 1 and 0 1 0 1. So no, I mean, okay, in this one it's straight, 0 0 1 1 then 0 1 1 0. The order, just do your order how you do it. Just keep the concept. The fields will be constant. So depending on your order, the outputs should have, there's some small errors here and there. So these are the combinations. So up is a 1, right is a 2, 3 is a down, 4 is a left. So you come have a 3 1 3 for the first one. So it's down, up, down. I'm just reading. This is minimal inputs. This combination, this junction, 4 wires, 3 inputs. But you can have better analysis. You have for here, here, entry, here, out, here, entry, here, and here. So you have it more detailed because it's faster to read them. You'll just read them. So we come, you say there's a kmap for writes. There's the first kmap. There's a, oh, this for up. Let me check. Kmap. This is right, this is left, this is up, this is okay. So there's a kmap for rights. Rights are 2s. There's no 2 in the first one. There's a 2 in the second one. There's a 2 in the third one. There's no 2 in the fourth one. So there's a 0 in the first one. There's no 2. There's a 1 in the second one. There's a 2. And then there's a 0. There's a, no, this is a mistake. This should be, the third one has a 2. So yeah, I've arranged it wrong. This should be 1, this should be 0. Okay, you get, but from this arrangement it's 0 1. This is inverted, it's not, it's wrong. Let me change it right now. So it's 0 0. There's a no 2, there's a 2, there's a 2. So yeah, these are 0, these are 1. So reading this, it's gonna be A B bar, or A bar A bar B. That's the output for this one. For the left, there's no 4 in the first one, there's no 4 in the second one, there's no 4 in the third one, there's no, third one, there's no 4 in the fourth one. So okay, so here is for right. This is for right. These came up for this one. Sorry, did this some while ago. So right is a 2. Can't remember which came up for which came up. 2. Give me a minute. Okay, so you get this up. So 0 0 came up for D, came up for C, came up for B. kmap for A. So A, B, A, B, C, D. So these kmaps are for this one, 0, 0, 1, 1. Sorry, I'm confused. So it's 0, 0, 1, 0, 1. So it's 0, 1, 0, 1. This is correct. Sorry. And then kmaps for give me a minute. Let me. Okay, you get the concept from here. There's some errors I'll finding it difficult to explain right now. Now for addition, you have the same one. There's two of them. This was for boxes, arranged in boxes, and then there's this one arranged in structured. So you read them in one line, 0, 0, 0, 1, 1, 0, 1, 1. So the magnetic fields are these ones: 1, 2, 3, 4, 1, 3, 1, 3, and then 3, 1, 3, 1, and then 3, 4, 3, 2. So when you come to the outputs, it's for addition. You add these two, 0 and 0, you get a 0, 0 and 1, you get a 1, 1, 1 and 1, no, 1 and 0. In this haven't followed gray code, so you get a 1, 1 and 1 for single bit, you get a 0. This is supposed to be a 0. And then for double bits, the first is, I've already explained this, they are zeros, and then these ones are the ones that add up. So when it sums up for 1 and 1, you get a 1 and 0. So it's a 1 and 1. Let me, how is it? I made a lot of errors. Oh yeah, it's the same. So 0, 0 and 1, you get a 1. 1 and 0, you get a 0, 1. And then 1 and 1, you carry the next bit here. 0, 0, you get a 0, 0. 0, 1, you get a 0, 1. 1 and 0, you get a 0, 1. And then 1 and 1, you get a 1, 0. So with the fields, having those fields, so this is the field for addition. It's supposed to be up to here. So this is the field for the other addition. So you have basic field. So and then there's one for multiplication, mult. 0, 0. This is the field. It will have this circle and then an X. So you map out the outputs in form of numbers. You get, and then this is the field for division. So these are the fields for division. In the division, there's a strong right, a rotation, a strong left, and then a rotation. Yeah. So let me. Sorry for the long video. It's kinda confusing. So I'll explain it better in other videos. So please do share, like, and subscribe. But make sure you use the fields for faster processing. That's the main idea. Oh, and keep the kmaps as constant. So have a kmap, character kmap for each and every character. So you just read kmaps instead of having to process. Yeah, processing will be done sideways. So it's a form of memory, a constant memory. So yeah, which is already there, but you're reading fields, not current signals. You'll need a lot of current for it, but the performance might be faster. So, but I'm not sure. All is better. All is well. So yeah. Thanks for watching.